Picture this. You're cruising down a Silicon Valley highway minding your own business when suddenly a car passes you that looks like it's wearing a disguise. Heavy camouflage wrapping, mysterious proportions, and something about it just screams future. Well, that exact scenario just happened. And what people captured on camera has the entire automotive world losing their minds. Because this isn't just another electric car prototype. This is potentially the vehicle that changes everything we thought we knew about affordable transportation. Now, I know what you're thinking. Another EV prototype? What's the big deal? But hear me out. Because what's hiding under that camouflage isn't just interesting, it's genuinely shocking experts who've spent decades in this industry. We're talking about engineering decisions that shouldn't be possible at an affordable price point, manufacturing techniques that sound like science fiction, and autonomous technology that might just settle one of the biggest debates in the automotive world. So buckle up, because what I'm about to show you will completely change how you think about the future of electric vehicles. Let's start with something that most people would just scroll past. Battery placement. I know, sounds boring, right? But stay with me because this is where things get absolutely wild. When you look at these spy shots, specifically that rear quarter angle, something immediately jumps out if you know what to look for. The floor sits unusually low relative to those wheels. And that tiny detail, it reveals everything. See, every electric car you can buy today uses what's called a structural battery pack. Basically, the batteries are grouped together in this big protective case that also helps hold the car together. It's smart engineering, sure, but it's also heavy and expensive. Now here's where your mind should be blown. This prototype appears to be doing something completely different. Something that engineers have been dreaming about for years, but couldn't figure out how to actually build. What if instead of putting batteries in a case and then putting that case in the car, you just made the floor out of batteries? Sounds crazy, right? Like who would glue hundreds of individual battery cells directly to the car's structure and call that the floor? Well, apparently, the answer is staring us right in the face through that camouflage wrap. Think about what this means for a second. Every ounce of packaging material around those batteries, gone. The mounting brackets and reinforcement structures, eliminated. You're suddenly looking at a car that's lighter, cheaper to build, and weirdly enough, actually stronger than conventional designs. Because when you bond those cells directly to the structure, impact forces get distributed across hundreds of connection points instead of through a few mounting locations. Physics just works better this way. But here's the thing that should really make you appreciate the engineering madness happening here. Making this work isn't like assembling furniture from a big box store. You're essentially saying, let's turn hundreds of battery cells into load-bearing structural components that also need perfect thermal management, complete electrical isolation and crash protection that works without the traditional armor plating. Oh, and by the way, those cells are going to expand and contract with temperature changes. So everything needs to accommodate that while maintaining structural integrity over years of use. No pressure, right? The fact that this prototype exists and is confidently cruising public highways? That tells us they've actually solved these problems. Look at where the body panels meet the lower section of the car. There's no visible lip, no mounting flange, no traditional battery pack edge, just smooth, continuous surfaces. That's not a styling choice. That's the signature of direct cell integration. And we're just getting started with the implications here. Check out the proportions of this vehicle. The ratio between the wheelbase and total length suggests they're packing more energy capacity into the same floor space compared to traditional battery packaging. Industry experts estimate this approach could improve space efficiency by 15 to 20%. For a car aimed at everyday buyers who need real-world range without premium pricing, that efficiency gain isn't just nice to have. It's the difference between, yeah, this could work, and there's no way we can make the numbers work. Same usable battery capacity, but with fewer cells, lower cost, less weight, and better performance. You're getting more from less. That's not incremental improvement. That's rethinking the entire equation. Now let's talk about charging, because this is where things get really interesting. The testing patterns we're seeing suggest something big. This affordable car might be running the same high-voltage architecture currently reserved for six-figure performance vehicles. We're talking 800-volt systems that enable charging speeds most people associate with premium EVs. Imagine pulling up to a charging station in your budget-friendly electric car and filling up as fast as someone in a vehicle costing 3 times as much. That's not just convenient. That completely erases one of the main reasons people justify spending extra money on premium electric vehicles. But here's what really keeps me up at night thinking about this. Direct cell-to-chassis integration isn't just an engineering achievement. It requires completely reimagining how you build cars. Your manufacturing processes, your supplier relationships, your quality control systems, everything changes. You can't just drop this technology into an existing factory and hope it works. You need validated production systems that can consistently build thousands of vehicles where the batteries are the structure. This prototype testing, it's validating that entire ecosystem. The manufacturing processes, the supplier capability, the quality systems, even the service procedures for when something needs repair down the road. Multiple prototypes operating reliably on public roads suggests they're close to having all of this figured out. We're looking at genuinely revolutionary battery integration that's nearly ready for mass production. Think about that for a moment. Making batteries serve multiple functions simultaneously. Energy storage, structural support, crash protection. This is the kind of systems-level thinking that separates companies that make minor improvements from companies that redefine entire industries. And it's all hiding under that camouflage wrap, being validated one highway mile at a time. But wait, because the battery innovation is just the opening act. Let's talk about what's happening up on the roof, because this is where industry experts are really scratching their heads. Take a close look at the roofline where it meets the windshield in these images. Those aren't just bulky camouflage covers making weird shapes. There are subtle bumps and surface irregularities that reveal something fascinating. Sensor integration for advanced driver assistance systems. But here's where it gets controversial. The placement patterns don't match the current camera-only vision system architecture we've seen in production vehicles. Something different is being tested here, and trust me, this has implications that could reshape the entire conversation around autonomous driving. For years, the strategy has been clear. Pure vision, no radar, definitely no expensive laser sensors. A camera-only approach that mimics how humans drive. It's been controversial, it's been debated endlessly, and yet it's been the committed path forward. But recent statements have acknowledged that complementary sensor technologies might have advantages for specific situations. And this prototype's roofline geometry? It suggests integration points for either additional camera angles, higher resolution imaging systems, or, here's the part that'll make people argue in the comments, possible validation testing of alternative sensor types. Now, before anyone freaks out, testing competing approaches doesn't mean production implementation. Smart companies validate their chosen path against alternatives to build confidence and identify edge cases. Maybe they're benchmarking vision-only performance against sensor fusion to prove their approach works. Maybe they're finding specific scenarios where additional sensing adds genuine value. Either way, the testing is revealing. Look at the front fascia details visible through that camouflage. The camera array appears more sophisticated than current production vehicles. The spacing and positioning suggest a stereo vision setup for improved depth perception. This is actually brilliant for an affordable vehicle because stereo cameras, while requiring precise calibration, provide more reliable distance calculations than trying to estimate depth from a single camera perspective. And computationally, they're simpler to process than complex single-camera depth estimation algorithms. For a mass-market vehicle where every dollar of sensor costs matters, stereo vision might be that sweet spot between capability and affordability. You get robust performance without premium pricing. But here's what you can't see directly, and it's possibly the most important part. The computing architecture processing all this sensor information. Current hardware represents substantial processing power, but future generations need even greater efficiency to enable autonomous features at price points regular people can actually afford. This prototype's testing patterns, especially in those highway scenarios we're seeing, validate the entire perception-to-action pipeline. Not just do the sensors work, but can affordable computing hardware process this data fast enough for safe autonomous operation in all conditions? Every single mile this prototype drives feeds training data and validates algorithm performance on the exact hardware that'll ship to customers. That's incredibly valuable validation you just cannot fake or simulate adequately. Real world, real traffic, real edge cases on production intent hardware. The sensor positioning also tells us something about the strategy. Hardware capable of advanced autonomous functions gets installed now, basic driver assistance features ship at launch, and then capabilities progressively unlock through over-the-air updates as software matures. This approach has defined the strategy for years, but pulling it off on an affordable platform? That requires even more careful balance between hardware capability and cost. Think about the specification challenge. The sensors integrated into this prototype must support not just current features, but unknown future capabilities that'll emerge from ongoing AI development. You're essentially future-proofing hardware for software that doesn't fully exist yet, all while keeping costs down. That's a remarkable engineering tightrope to walk, and consider what this validation really means. They're not just testing sensors in isolation. They're validating the entire autonomous driving software stack on production representative hardware. Every scenario encountered feeds training datasets. Every sensor anomaly informs hardware specifications. Every software iteration proves computational requirements. By production launch, thousands of hours of autonomous operation will be validated on exactly the hardware customers purchase. Most automakers only achieve that level of real-world validation after production launch, if at all. These seemingly ordinary highway test images, they represent crucial milestones in affordable autonomous vehicle development. The debate around sensing approaches will define autonomous capabilities for years to come, and this affordable platform might settle some long-standing arguments once and for all. Now let's shift gears entirely and talk about something that sounds boring but is absolutely mind-blowing when you understand it. Manufacturing. I promise this is more exciting than it sounds, because what's happening here literally changes the game. Looking at these highway test shots, the first thing technical experts notice isn't what you can see. It's what the proportions reveal about what's underneath. Check out that front overhang. It's noticeably shorter compared to other models, while maintaining what looks like a substantial wheelbase. This isn't some designer's aesthetic preference. This is the physical signature of completely reimagined manufacturing processes. Traditional vehicle assembly requires body panels to wrap around a structure that's built sequentially, one piece at a time down an assembly line. Those requirements create certain dimensional compromises you just have to accept. What we're seeing here suggests those constraints have been eliminated entirely. Instead of one moving assembly line where the car gradually takes shape, imagine building major sub-assemblies in parallel. Front module, rear module, battery pack, interior capsule, all being optimized independently before final integration. The technical advantages are massive because each module can be engineered to its performance limits without compromising other systems. Notice how the wheel sits pushed toward the vehicle's corner in that front quarter view. That's not aesthetics. That indicates the front module likely integrates the motor, suspension, thermal management, and crash structure as a single pre-validated unit. Traditional assembly can't achieve this integration density because workers need access from multiple angles throughout the build process. You physically cannot assemble something that tightly packaged on a traditional line. The real innovation reveals itself when you think about manufacturing scalability. Claims suggest this process can reduce factory footprint by 40% while increasing production speed. How exactly? By eliminating the sequential bottleneck. In traditional assembly, every station must finish its work before the vehicle moves forward. Your entire production rate gets limited by your slowest station. One slow process backs up everything. With parallel subassembly construction, each module builds at optimized speed, stores briefly if needed, and integrates only when all components reach readiness. The slowest process no longer holds up everything else. Look at how the camouflage breaks at certain vertical planes in these images. Those likely correspond to module separation points. This isn't speculation. The design specifically accommodates this manufacturing approach. But here's what's really got industry analysts debating. The thermal management integration visible even through all that camouflage. Look at the lower front fascia. Those aren't conventional air intakes. The geometry suggests active aerodynamic shutters integrated directly into the structural module. And the suspension mounting points visible through the wheel wells? That attachment geometry indicates multi-link rear suspension, typically reserved for premium vehicles due to complexity and cost. Why would anyone use expensive suspension architecture in an affordable car? Because this manufacturing process allows building the entire rear suspension module, including all the links, bushings, dampers, and mounting structure, as a single subassembly that drops into the vehicle in one operation. The assembly time savings offset the component cost premium while delivering superior ride quality and handling. This is engineering optimization at the system level, not just making individual components cheaper. Exactly what this manufacturing revolution enables. Think about what this means for the future. Affordability without compromise. When you're willing to reimagine entire vehicle systems from first principles, building manufacturing processes, structural architectures, and autonomous capabilities specifically for mass market production rather than just adapting premium vehicle approaches and hoping to cut costs somewhere. This isn't just a cheaper electric vehicle. It's a vehicle delivering capabilities previously exclusive to premium segments at prices enabling widespread adoption. What you're witnessing in these prototype images isn't just the next product launch. It's a complete rethinking of how affordable electric vehicles can be engineered, manufactured, and equipped with advanced technologies. The prototypes continuing their testing and validation are showing us exactly how this transformation happens. The path to affordable, capable electric mobility runs through this kind of systematic innovation. Not just making existing technology cheaper, but creating entirely new approaches that change the fundamental cost structure of vehicle production. And based on what we're analyzing in these prototypes, we're closer to that goal than most industry observers realize. So here's what this all adds up to. Battery integration that makes the impossible possible. Autonomous sensing technology that settles debates. Manufacturing processes that eliminate compromise. We're watching the future take shape under camouflage wrapping on public highways. Every test mile validates technologies that'll reshape transportation. Every design decision proves that affordability and capability aren't opposing forces when you're willing to rethink everything from scratch. This is what revolution looks like before the world recognizes it. Not dramatic announcements or flashy reveals, but heavily camouflaged prototypes accumulating validation miles, proving out technologies that shouldn't work together, but somehow do. The electric vehicle that changes everything isn't coming someday. It's being tested right now, hiding in plain sight, waiting for the moment when all these innovations come together in something anyone can actually buy. If this deep dive gave you a completely new perspective on what's actually happening in the EV world, do me a favor and smash that like button, because there's so much more coming. Every new prototype sighting, every technical detail that emerges, we'll be here breaking it down and showing you exactly what it means. Hit subscribe so you don't miss a single analysis, because trust me, the developments coming in the next few months are going to be absolutely wild. Until next time, keep your eyes open when you're on the highway. That weird-looking camouflaged vehicle passing you, it might just be carrying the future of transportation. And now you know exactly what to look for.